So today I'm going to take you through just a few examples of the tools and technologies that we have on campus. And in the background, we're going to see some snippets of the projects from the past through which these tools have been deployed. So each of the 4 studios use these technologies in different ways. And the studio briefs are designed to be taught in conjunction with those technology seminars that Natasha mentioned to deliver instruction on the tools used in each studio's projects. So in the past few years, technology seminars have looked at the creation of interactive playable games, the development of fully immersive VR environments, image production using machine learning and generative neural nets, robotically automated 3D printing and fabrication, spatial sensing and the autonomous navigation of robots, and VFX workflows for fully rendered and composited worlds. And so to give a general overview of the technologies that will be available for you to explore, I'm just going to split the tools into 5 main categories. So automation, fabrication, mixed reality, environment sensing and capture, and computation. And so in terms of automation, we have the 4 robots, 2 large and 2 small, and these are able to execute motion-controlled movements either in real time or in pre-programmed paths. So in the past, seminars have investigated using these for projection mapping, for interactive installations, and for large-scale 3D printing and rapid prototyping in clay and concrete. And during remote instruction, the technology studio took over these robots and enabled them to be remote controlled by students from their own homes. In addition to the robots, we also have an autonomous micro vehicle known as a TurtleBot. This small bot is fully mobile and it's able to use a series of onboard sensors to map the space around it and allows it to autonomously navigate new environments. So it's been used extensively by the Mobility Now Arrival Studio to test and simulate how self-driving vehicles might one day operate in urban and natural environments. And so the robots also open up this potential for motion-controlled camera movements. So we can attach cameras to the robot arms and get repeatable, highly precise camera movements that can be carefully pre-planned in software and allow us to composite multiple shots with the same camera path over one another to achieve these extremely smooth choreographed movements. In terms of fabrication, we've got a generously sized woodworking workshop you saw in that photo from Natasha, and a CNC machine, and a range of 3D printers that can print in different filament types. And depending on the studio and seminar briefs, sometimes you'll be asked to use these in your assignment workflows, in which case you'll be allocated some of these machines, or at other times, jobs can be booked through our lab manager based on availability. And so in the past, students have used these printers for constructing site models, but also for creating scaffolds for virtual and augmented reality experiences, where custom fabricated objects correspond to virtual objects in digital immersive environments. And these tools have also been used in past tech seminars to make folding, inflatable, and actuated prototypes for dynamic architectures. In terms of mixed reality, our campus has a wide range of VR and AR devices. So we have a couple of Vive Pro VR headsets as well as Oculus headsets. And these tools allow for 6 degrees of freedom in virtual environments, meaning you've got full control over the orientation of your perspective and full ability to move around with your body in VR. And we also have a Magic Leap augmented reality headset. And past technology seminars have looked into creating mixed reality experiences that merge digital animations and physical models using projection mapping. And we're currently also trying to develop a media lab in one of our seminar spaces to accommodate real-time motion tracking. So some of the current research that's taking place involves real-time facial and body performance for piloting digital humans. In addition to our virtual reality equipment, we've got a range of gear for capturing real-world environments. So we have a Blackmagic 4K cinema camera and lens kit, as well as electronic stabilizers and tripods to allow students to shoot models, installations, or short films at cinematic quality. We have DSLR cameras, a range of GoPros, and a 360-degree panoramic camera, which can also be used to capture full spherical environments, and potentially could be used to capture custom environments and HDRIs for lighting your scenes in renders. And students have used this camera equipment alongside studio lighting to start to capture high-resolution photogrammetry of objects, interiors, and buildings. So another part of the media lab that we're working on is a semi-automated station for photographing objects and models from all angles, so that we can create digital replicas of them in high detail. And so finally, our lab also has considerable computational power. We've got 8 desktop machines that are equipped with RTX graphics cards, and these can be booked by studios and seminars depending on their needs. And we maintain licenses for high-end modeling software like Maya, Cinema 4D, and Octane, as well as for the game engines Unity and Unreal Engine. And in these game engines, students have developed simulations and scripts for how virtual agents might wayfind and intelligently navigate virtual environments. But these machines have also been used to train machine learning algorithms to create generative imagery. And they've also served as render farms for rendering full VFX short films. And so some of the cinematic worlds produced across the studios have gone on to be exhibited or screened at film festivals in LA and in students' home countries. And so the idea behind a lot of this technology that we're trying to build is to aim to provide you with examples of some of the latest workflows and tools that are being deployed in the wider industry. So as Natasha's already mentioned, alongside these seminars and studios, each of the studios invites industry guests to lectures, reviews, and workshops. And we organize then visits to professional studios so you can see how the technology you're using is being deployed at a much bigger scale. So this is from that visit to the NAT Studios virtual production LED volume that Natasha mentioned before, where game engines are currently being used to create real-time backdrops for Hollywood films. And so I'm going to wrap it up pretty soon. So I'm hoping that gives you an idea of the range of technological options that are facilitated at Ideas, and the applications shown here are just some of what would be possible with this equipment. So within your courses here and between your studios and their associated technology seminars, you'll work with faculty to decide how and if these workflows might be explored in your specific projects. And we're always really excited to hear from prospective students what processes they'd like to experiment with and research.